Right, good day, everyone. You're welcome today to the continuation of our training sessions. And today we want to continue with hypothesis testing. Hypothesis testing. Last time we mentioned few things about hypothesis testing, and I remember that I mentioned that uh, before you can make conclusion on any statistical data, you have to test the hypothesis. And when we're testing hypothesis, there are two things that are associated with hypothesis testing. That means hypothesis testing or hypothesis itself is of two different types. We have the null hypothesis and then the alternative hypothesis. So you have to set the null hypothesis and the alternative hypothesis of your study before you embark on that analysis. And once you're able to confirm that your data follows a normal distribution, then you can choose the type of parametric analysis that fits the type of analysis you want to do or that fits the objective of your work. Okay, so last time also I tried to show us different types of hypothesis testing. And I think I remember, let's go to assistant. If you open your Minitab software, go to assistant and then hypothesis test. So when you click on hypothesis test, we're going to see different types of objectives, beginning with if you are comparing one sample, you are comparing one sample with a target, with a particular target, then you have the different types of hypothesis analysis or tests that you can use. If you're comparing two samples with each other, you also have different types of hypothesis tests that you can use. And then if you're comparing more than two samples, you also have different types of hypothesis tests that you can use. So if you're comparing one sample, I mentioned last time that you can do a one sample t-test, which I showed you, if you're comparing with a particular target, and if your data follows a normal distribution, that means if your data is a parametric data, then you use a one sample t-test. Now, our focus in this training are the tests that are commonly used by different researchers. The tests that are commonly used. We are not really focusing on those tests that are not commonly used among researchers. But if you have questions related with a particular test, then you can bring it up during the live session. We can look at it together and see how we can scale through it together. So I'm going to be demonstrating how to do a chi-square goodness of fit. Because the last time we talked about the one sample t-test, which is more like if you're using a parametric data, a data that follows a normal distribution. So we can use a one sample t-test. Now, if you're using a data that is categorical in nature, for example, I prepared, let me just minimize this and let's go to, so we're going to be looking at chi-square goodness of fit today. And also I will also look at chi-square test for association. So if you're comparing two samples now, but let's start with comparing one sample, which is a chi-square goodness of fit. So let me close this assistant, all right? Now I prepared this data that we're going to look at today, and I will give a brief explanation of what this scientist or this researcher did. A researcher who happened to be a public health researcher who was working on public health studies actually did some survey. He used questionnaires to collect data. Now, sometimes people in social sciences also do the same. You administer questionnaires to respondents, and then you retrieve the questionnaire after they have filled the data. You ask them a series of questions, and then after they have filled the data, you now supply the information on the computer, on your Excel. So the same thing this researcher did, all right? He collected, he administered questionnaires to some respondents, and then he collected some biographical information of those respondents, all right? Their sex, that's the gender now, the age, how many of them are living in a room, the age of each respondent, the kind of residence that they are living, and then the facility where he collected, or the facility, that's the healthcare facility where he collected those data, where he met those respondents to collect the data. So the researcher now supplied the data to the computer, to the Excel, and then let's look at the data briefly. We have the gender, which is the sex. F represent female, M represent male. So, and then he focused on those two gender, and then he now, he collected the data. Then he collected the samples from them, all right? After he collected their blood samples, he now tested the blood samples against some common antibiotics to see whether their blood are susceptible to the antibiotics, or whether the antibiotics have an intermediate effect or action, or the antibiotics has a resistance, or there is a resistance, to the antibiotics in the blood samples that he has collected. So he represented S, he used S as the susceptibility to the antibiotics, high as intermediate response to the antibiotics, and then the R represents resistance to the antibiotics. So he used how many antibiotics? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. About 10 different antibiotics. So our focus is not on all the antibiotics. We just want to pick 1 or 2 of them as an example and see what this researcher was trying to achieve. Now let's look at the other data. He also collected data on the room occupancy, how many of them are living in a room, to see whether the number of occupancy in a room has an effect on how the individuals respond to the antibiotics, all right? You also look at the age, whether the age has a role to play, has a role to play in the response of these, respondents to the antibiotics. You also look at the residents, the type of residence where they are living. All right, so we'll just look at, run through this data and then see how we can achieve, this. Now, the first thing we want to do is the chi-square goodness of fit. So when you're doing a chi-square goodness of fit, what is in your mind is that you are comparing just within one variable. And in that case, our variables are the antibiotics, not the biographical information of the respondent now. Is the antibiotic to see whether the antibiotics, the antibiotics has 3 different levels or categories. That's why I call it categorical data. You have the S, which is the susceptibility. You have the I, which is the intermediate. Then the R, which is the resistance. So we want to see whether there is an association between these susceptibility, intermediate, and then the resistance of the antibiotics for within each antibiotics, for each antibiotics, to see whether there is any association at all, whether there is a significant, that's the right word, whether there is a significant association, all right, within each antibiotics with respect to the resistance, the intermediate, and the susceptibility. So if you have this kind of data where you are trying to compare within one variable, this is the right type of analysis that you can use, all right? And then it is a categorical data. You can see there is no figure here, there is no numerical factors here, numerical numbers. All of them are all categoricals. So that tells you that this is what you can use to test such a data, all right? So let's look within each of them and just run through. So if you want to do chi-square goodness of fit, first you go to Start, click on Start on the menu bar, and then you just go downward and click on Tables. When you put your cursor on the table, then you can drag it to the right and click. You can see different types of chi-square tests here. It's put under tables because it's like, it's arranged as a table, all right? It's a tabular kind of analysis. So just click on chi-square goodness of fit. And you can see it's even showing one variable inside in front of it to tell you that this is the kind of analysis you can use. So just click on chi-square goodness of fit. All right. So when you come here, if you have observed, let me delete this. If you have observed count, if your data has to do with counting, like I said in my, I think one of the first few videos that I released, when you're dealing with count data most times are data that might not be normally distributed. So such data have to be tested using a non-parametric analysis. All right. So if you're using a count data, you can click count. If you have 1, 2, you understand, 1, 2, or 3, just within a fixed value, those count data, you can just click. But in this case, our data is categorical. So just select categorical data and then click inside the box in front of it. So you now have to pick which of the antibiotics you want to test. All right. So let's start with ciprofloxacin. All right. So just double click on this and then it will come inside the box. Then you come under the test. The kind of test that we want to use is equal proportions. Just like all of them is assigned an equal proportion. So, which is the common one. Just click on equal proportion. Then come to graph. Let's see whether we can get some graphs from here. All right, so we can also get a bar chart of the observed and the expected values. All right, and then the bar chart of each category's contribution to the chi-square value. All right, so just click on all of these and click OK. So when you click OK, then come here and click OK again. All right. So Minitab has been able to run the analysis for us. So let's draw this cutting downward and then let's see the analysis, the result of the analysis. Now, Minitab tells us now that the category IRS of these antibiotics, each of them has this proportion, all right? We assign equal proportion so that to give them equal chances of expressing themselves, in that analysis. And then this is the expected, contribution that is expected of them. And this is the contribution to the chi-square. You can see the difference between the expected and then the observed contribution. Now, this is where we are really interested in the chi-square table itself. This is the chi-square test, all right? And then you can see under the chi-square, our focus is this value and this p-value. Now, the chi-square value is 27.30, and then the p-value is 0.00. You can see the p-value is far less than 0.05. Okay, now let me just try to say something a little bit. The first thing, like I said, when you want to test is to set an hypothesis. So our hypothesis in this case for chi-square, the null hypothesis would be that there is no significant association, all right, between these categories of the antibiotics. There is no significant association. That should be our H0, no significant association. So our HA, which is the alternative, will now be there is significant association. So in this case, if our p-value, and then we'll set our threshold p-value as 0.05, like I explained in the last video, it is like a 95% confidence you have in the result, the data. So 95% or 5% probability, which is the same as 0.05. So it is the most commonly used one. You can also increase your threshold depending on the kind of analysis you are doing or the type of degree you want to earn. Sometimes if you are doing a PhD degree, you might increase your threshold level to 0.01, which is like a 99% confidence that you have in the data, and is a 1% probability. Okay, it's more higher than 0.05. So in this case, even if we had set it as 0.01, we would still have gotten a significant association. So this tells us that there is a significant association, okay, between the I, the R, and the S for these antibiotics. Okay, so now let's check the other chart. Let's see the chart. You can see the chart different between the expected and the observed. The expected is shown as this, the observed is. So you can see how chi-square is able to give us the bar charts. So you can do anything you want with this chart. You can use this chart for your study. You can just send it to Microsoft Word, or you can copy the graph. and then paste in your Microsoft Word. And if you want to edit the graph, you can also do all manner of things when, to edit. You can click on edit of the graph. Let's click on edit the graph, and then you can see anything you want to do with the graph can be done here. All right, just be as flexible as possible, and then you can then click OK once you are done with the editing. That is not what we are doing today. So let's go down again. You can see the contribution of each category to the chi-square. And you can see that the susceptibility contributes more to the chi-square, all right? So that is what we have seen with these antibiotics. So can we go to the, let's go back to statistics, tables, all right? Chi-square goodness of fit. Let's see whether we're going to see another trend with another antibiotics. So click back on this box, delete this one. Okay, so when you delete this, so let's pick any antibiotics. Let's pick amoxicillin. Double click on amoxicillin to come here. Then every other thing remains as we have set it at the beginning. So click OK. So when you click OK, you can see what we see, or what our Minitab has been able to give us. You can also see this table of observed and expected counts. These are the expected, these are the observed. You can see their contribution. S still contributes more to the chi-square. So let's look at the chi-square table. Now, in this case, the chi-square table, we have a chi-square value of 9.17, and the p-value is 0.01. So the p-value is still less than 0.05, which still tells us that there is a significant association between the categories of the antibiotics. Now you can see the chart also, and then the other charts. Okay, so this is how to do a chi-square goodness of fit, all right, to test your categorical variable and to see whether there is a significant association, all right, between the categories that you have in the variable. Now we're going to go a bit more complex to compare two variables now. Two variables, and see whether we can now associate the antibiotics with the demographical data that we have, we have mentioned earlier on. So in that case, let's go back to assistant, go to hypothesis test. Or I just want to do a recap. So you can see if our objective is to compare two samples with each other, then it is chi-square test of association that you will use, because it compares, between two different independent variables, okay, to see how they are associated with each other. So that is what we're going to, you can still go from here and click chi-square test of association the same way you can go from here and click on chi-square goodness of fit. So you can either go from this assistant, or you go to the start menu, the start bar rather. Okay, so but let's click on here. Okay, so click on this one, and then we can continue with the chi-square association. All right. All right. So let's go to start. Let's pick it from start. All right, let's close this. So go to start. All right. Then click on tables, and then click on chi-square test for association. So click on this. When you click on this is going to come up. All right. So let me just delete what I have inside here so we can select afresh. Now you can select from this box. Do you have your raw data as categorical data variables, or you want to summarize data in a two-weight table? But because our data is categorical, just click raw data categorical variables. All right. So click inside this row. Now in chi-square, one of the variable has to represent the row, while the other one will represent the column. Now, in this case, since we are trying to test the association between the antibiotics and then the demographical data of the respondents. So because we're trying to compare these two, we can use the respondent data as the row. So you can, let's start with the sex of the respondent, the gender. So you could double click on sex. So it's going to come inside the row, and then we can then pick each antibiotics and then see how the gender of the respondent has a way to contribute to the responses of the antibiotics. So let's click on any of them. So let's start. You can click on ciprofloxacin, double click on it, so it will come here. So click on statistics. So when you click on statistics, this already pre-selected, so you can just leave it like that. Chi-square test is what we want to perform. Display count in each cell, display marginal count, statistics to display in each cell, expected cell count. Anything that you are interested in, you can click on adjusted residual if you want it to show you. You can say each cell's contribution to chi-square. You can also click on it so that you can just have as many parameters as possible. So click OK. Then let's go to option, click on option. What are the things that we want to see? If there are missing values, let it be displayed, okay? Include displayed missing values in the calculation. If you want the missing value to be included in the calculation, you can click on that. In any way, you can just leave it like that. So click OK. Now, since we have selected everything, then click OK. All right, so Minitab has already given us the answer. So we can just draw this downward, okay? And then let's see what we have here. Now, Minitab tells us that these are the contribution, all right, of the of each gender, okay, the category of the gender with respect to the categories of the antibiotics. But this is not where we are going. Our focus is on the chi-square test. Now, the chi-square test, this table is our focus. Now, the chi-square test of association is giving us, under chi-square, is giving us two different kind of parameters. And I'm going to tell us the one that, you know, is important that we normally use, okay? So you have the Pearson chi-square, which is more like a kind of correlation thing, which is not really our focus. The main thing that we're interested in is this likelihood ratio. The likelihood ratio is the one that tells us the exact chi-square value that we are interested in. So this is the chi-square value 0.805, all right? The degree of freedom is 2. Then the p-value also, which we are interested in, you can see the p-value is 0.669. In this case, the p-value, all right, because our hypothesis, the null hypothesis is that there is no significant association between the gender, the sex, and then the antibiotics responses. So now this is already giving us a confirmation of our null hypothesis because the p-value is more than 0.05, which means that there is no significant association between this. Whether you are a male or you are a female, you can still, the antibiotics will still perform its function in the respondent because the researcher worked on some specific respondent. So the result is coming from the respondent that were worked on. So now this is telling us that among the respondents, it doesn't matter whether they were male or female, the antibiotics still had its own separate kind of responses. So you have 0.669 as a p-value. So even then, if you compare even these two types of chi-square, you will see that their values are almost the same. The Pearson also, you have the 0.79, which can also be considered as 0.8. Then you have the p-value also is 0.67, which is almost the same thing as this one. Also, when you now do a kind of, you're trying to, summarize it, you have 0.67 as well. So you can see it doesn't even matter whether you pick any, but our focus more is this likelihood ratio. Now, so let's take the second antibiotics and then see what we have. Or we can compare these antibiotics with another demographic data of the respondent. So let's go back to start. Go back to start. Then tables, under tables, click on chi-square test for association. And then we can change this one from sex. Let's change it to age. Let's look at age of the respondent. Okay, so double click on age. Still talking about the same antibiotics. Every other things that we chose earlier is still the same. So we don't need to go back to statistics and options. So let's click on OK. So when we click on OK, you can see what we have here, right? You can see the results. Let's go to the result. You see the results. There is something missing here. The chi-square is telling us that the likely ratio is 13.79, but the chi-square approximation probably invalid. Probably there was something wrong with the data itself. But of course, we can see the chi-square test. The only thing that we could not see here is the p-value, all right? So and then it says that 10 cells with expected counts less than 5. I think that's where the issue is with the data. There are some counts that are less than 5 in that data. So let's check another thing. Let's check another data. Let's go back to statistics, tables, chi-square test for association. Okay. Then let's change this age to room occupancy. Room occupancy, let's see what it has to tell us as it relates with the antibiotics. Then let's click OK. Okay, so you have these are just like the summary of the data. So if you want to prepare your table for your thesis or your dissertation, you can use this table as your summary table, and then you can put the chi-square test there. So we still have almost the same thing here, all right, almost the same thing. So, but we can see the likely ratio, the chi-square is also there, and then the p-value is also omitted, maybe because of how the researcher collected the data. So let's check another one again. In this case, I'm going to change the antibiotics. Let me change the antibiotics to another antibiotics. Let's click on ceftriaxone, okay? And then let's see, let me change this room occupancy to another one. Let's say the facility where the result was collected. Okay, then let's click OK. So let's see what we have here. All right, here in this case we have the likely ratio is 9.946, and then the p-value is 0.04. So you can see here the p-value is also less than 0.05, which means that there is a significant association. You can see now that this result is telling us that let's go to the summary table above. The researcher collected these samples from 3 different facilities, DASH, GHD, and PHC. These are the different types of hospital facilities where he collected the data from. And then you can see, so the result is now telling us that the hospital facilities has a significant association with the reactions or with the responses of the antibiotics among those respondents. That means the categories of the antibiotics has a significant association with the facility where those respondents were admitted. So these are the different kind of results you can get when you're doing a chi-square test. Basically, chi-square just gives you a test of association. It gives you how related are these different variables together. And don't forget, when you're doing a chi-square test, your variables must be either categorical or non-parametric in nature. So you cannot use it for particularly for variables that are not categorical, or they are parametric variables. And most importantly as well, chi-square test is to test for association. So the objective of your study has a lot to tell in the type of analysis that you will do. Please don't forget that it's very important in any research, whether you are in social sciences, you are in earth sciences, you are in sciences, you are in engineering, like what the data we just consider now, that data can also, you can also use it for any other data. If you're in social sciences, you have collected, you have administered your questionnaires, and then you want to test for association, between the demographic data and some of the other variables that you collected in your data, you can use a chi-square test. So I think I'm going to stop here now. Then the next time we're going to come up with another hypothesis test, which is like the last one on the hypothesis test, which is the ANOVA, analysis of variance. I mentioned earlier that our focus is on the most commonly used analysis, that researchers use. So if you have any other thing that is bothering your mind and you want us to look at together, then that can be done separately. So we can then consider it together and then see how we can navigate it together. So this is how to do a chi-square goodness of fit and also a chi-square test for association. All right. So we meet again during the live session where we can then run this analysis together in a live session, and then we can also take some interactions, from you guys. So thank you very much, and I want to wish you a nice day. Bye-bye.